Good day, ladies and gentlemen. This is the start of our series on AP Physics 1, and we're doing a little bit of an introduction today. So let's start right off here with the units. This is a very important concept of any science course, and in physics, it's especially useful to be able to use units to your advantage as you're struggling to figure out a problem. So let's start our conversation off with the three fundamental units, as we will be dealing with them in Physics 1. So the three fundamental units measure the three fundamental quantities, those being mass, time, and space. Okay? So those are the only three quantities that will exist in the Physics 1 course, and all other quantities can be expressed in terms of these. Fundamental unit for mass is the kilogram, kg. The fundamental unit for time is the second, s, written as such. And in science, the fundamental unit for space is the meter, written as a lowercase m. Okay? So these are the three fundamental units. And all other quantities that we will be encountering in the physics class will be able to be expressed in terms of these units. Now, when I say a quantity, let me define what that is for anyone who's a bit fuzzy. A quantity is sort of a characteristic that you measure. Mass is a quantity. Kilograms are not a quantity. Kilograms are a unit. Okay? Time is a quantity. Energy is a quantity. Distance is a quantity. Data that you can collect. Okay? So when I say that we will be able to express any quantity in terms of the three fundamental units, let me give you an example. Energy is a quantity that we will be looking at in this course. Energy has units of joules. Now, what does that mean? I thought Meek just said that there are only three fundamental units. Well, there are only three fundamental units. Joules is a derived unit. Means joules is a unit that is derived from the three fundamental units. All the other units you're going to see in this course will be derived units. Joules, or 1 joule, is equivalent to 1 kilogram meter squared per second squared. So your understanding of units will further reinforce your ability to understand the equations that we're going to be dealing with in this class. Now I'm going to say and write out a few equations that we're going to be dealing with much later. You're not supposed to know them as of right now, but I'm going to use them to illustrate how units can aid your understanding of this. So one of the most central and fundamental equations that we're going to see in AP Physics 1 is the equation F equals ma. Force equals mass times acceleration. Okay? So force is given in units of newtons. Mass is given in units of kilograms. Acceleration is given in units of meters per second squared. Okay? When we say per, that always indicates a division bar. Meters per second, cats per hour. Cats divided by hours. Okay? So as you can see in the equation, and in any equation that you will be writing or deriving in this class, the units must agree. And like I said before, 1 newton is the equivalent of 1 kilogram meter per second squared. And if we look at this side of the equation, we are multiplying a kilogram by a meter per second squared, which gives us a kilogram meter per second squared. Okay? For those of you who have never seen this dot before, that means multiplication. But not only is the equation obeyed in real life, the equation is also obeyed in terms of the units. The units must agree. Okay? So, that understanding of units then allows us to understand a new concept that those of you taking algebra are going to encounter in this class, a new math concept, that is. So for those of you who have taken calculus, or are taking it right now, you will have heard of this before, but this is an algebra-based class, so I assume most of you have not taken calculus. In this class, we are going to be looking at graphs. And a very common way that us in AP Physics 1 are going to look at the graph is, let's say I have a graph of a straight line, you may often be asked to find the area under the curve, okay? Now, looking at it visually, it's not hard to identify what the area under the curve is. Now, of course, we would need to specify between what points. Let's just say, for simplicity, between x equals 0 and x equals 10. Find the area under the curve between those 2 points. And as you might expect, the area under the curve is simply this area bounded between our function, the x-axis, and our bounds. So finding the numeric value of the area under the curve is as simple as looking at the shape of the curve, recognizing the fact that in this particular case it's a triangle, and you would also have a numbered y-axis. Let's just say that this ends at 10. If I wanted to find this area, I'm sure we all know our geometry, that the area of a triangle is the base times the height over 2. So finding the numeric value shouldn't be a difficult part, but rather interpreting what it means, okay? So every time you're given a graph, you will be given quantities that are graphed on the x-axis and the y-axis. Okay, so let's just say, for example, that on the y-axis you are graphing velocity. Okay, I'll explain velocity in more depth in the next video when we start Unit 1, but for preliminary purposes, velocity is just speed. Okay, and speed is going to be measured in meters, distance, meters per second, okay? Because it measures how many meters you travel in each second. So those are the units that will represent velocity. Velocity will be represented in meters per second, all right? And this is going to be a graph with respect to time on the x-axis. Time would be measured in units of seconds. This would be a graph that, given this line, we would understand that at any particular point, let's say at time equals 4 seconds, we would be traveling at, let's just say, 4 meters per second, okay? Now, if I asked you to find the area under the curve, you would need to interpret what exactly that area represents, okay? So, like I was alluding to before, when we do any equation, when we do any combination, we need to pay attention to what our units are doing. So in this case, we are doing the base, which is 10 seconds. We're doing our x-axis 0 to 10, which is in units of seconds times, so 10 seconds, times the height of our y-axis, which is 10 meters per second, and we're dividing that by 2. And the 2 does not have units because it is simply a constant in the triangle area formula. It is not participating in the graph, okay? So if we get that, we get 50, but let's pay attention to what our units are doing. We're taking seconds and we're multiplying it by meters per second, all right? If we look at that, our seconds cancel out and we're left with the units of meters. Therefore, the area under the curve would be 50 meters. Okay? So what this area under the curve is signifying for us is that I am going to be traveling at some velocity, and I'm going to do that for some amount of time. Okay? Velocity times time, if I travel at a speed and I do that for a certain time, I'm going to travel a distance. Therefore, velocity times time equals distance, or displacement, okay? So here, the area under the curve represents a changing velocity, because the velocity is not constant in this case. And we're traveling at a given velocity for a given amount of time. Therefore, we are left with the distance traveled in that amount of time, 50 meters. Therefore, we can say that the area under the curve of a velocity versus time graph gives you displacement in units of meters. Okay, we're going to see that popping up in subsequent units. Now, I'd also like to cover notation as we go into this class, because for the overwhelming majority of you, this will be your first physics class. Okay, we will be representing quantities. Remember what I said about quantities earlier. Quantities are characteristics, they're data that you measure. Let's take time, for example. So let's say for the time being that we're using the letter T to represent time. All right, that you would say at time T equals 4 seconds times T equals 4, even right, the velocity is 4 meters per second, or V equals 4 meters per second. Okay, and in this case we're using V to represent the quantity velocity. Another important concept of notation here in AP Physics is we are going to use subscripts. Let's say time sub 0. This would be read as time naught, or T naught. The subscripts are used to differentiate between different quantities or different instances. Like, let's say we take a velocity measurement at 4 seconds and we take a velocity measurement at 6 seconds. Okay? We could designate the 4 seconds as time naught, and we could designate the 6 second time as T sub 1. So the letters that we use to represent quantities need to be exclusive. You can't have T represent both time equals 4 seconds and time T equals 6 seconds. That would be confusing, so you need to use subscripts to differentiate between quantities. Another example would be force. Force is conventionally represented with a capital F. You could write F sub G to represent a gravitational force, F sub N to represent the normal force, F sub A to represent an applied force. And the subscripts are largely up to your own discretion, but let's try and make them make sense, right? Realize that the normal force would naturally be represented by an N. The applied force would naturally be represented by an A. Okay, so let's take a look at how some of this notation is applied in your Physics-y reference table. I highly recommend that you take the time to print this out and you reference it along with me, because I will be referencing it ubiquitously throughout the unit videos that we're going to be doing here. So at the top of, the very top of your equation sheet, second page where you're given all your equations, let's take an equation from that, for example. The equation at the very top is V sub x equals V sub x naught plus A sub x times T. Okay? So that's a perfect example of how our notation is being applied. We have the letter T representing the quantity time. As you see on the right side of all your equations, you are given what each quantity is represented by. Like at the very top, you see a lowercase a representing acceleration, a capital E representing energy, and so on and so forth. So we're given that the lowercase letter t represents time, the lowercase letter a represents acceleration, the lowercase letter v represents velocity. Now, I fully expect that you are not entirely familiar with the concepts of velocity, acceleration, etc. Those will be explained in subsequent units, next unit, actually. But what we're trying to focus on here is the notation. So the notation x is used to represent that this is the velocity in the x direction, because velocity is something that also has a direction. When you drive your car, you are driving your car south or southwest. Velocity is in a particular direction. That is in comparison to mass, where mass, you cannot have mass in a particular direction, mass just exists. However, velocity or speed, you can travel in a particular direction. So this x subscript represents that we are traveling in the x direction. This x subscript again symbolizes that we are traveling in the x direction. And the naught, the 0, represents that this is an initial velocity. Ubiquitously throughout all science courses, when you see the naught, the 0 subscript, it means that is your initial value. Alternatively, you could write v sub I to represent your initial value. That's beside the point. So your velocity in the x direction is equal to your initial velocity in the x direction plus your acceleration in the x direction multiplied by time. Again, I don't expect you to understand the equation, I just want you to see the notation in physics in practice. Beyond that, let me build off what I was just getting at earlier with direction. In physics, we have two types of quantities. We have vectors and scalars. Vectors are any quantity that has a value, like let's go back to the speed example. You could travel at 25 miles per hour, that is the value of the quantity, and a direction. You could travel 25 miles per hour north. A vector has both a value and a direction. In physics, we call the value the magnitude, okay? So we would say that the magnitude of John's velocity is 25 miles per hour. They have magnitude and they have direction. The direction of John's velocity is north. Vectors have both. Scalars have only a magnitude. Let me reintroduce my mass example. You can only have a mass of 20 kilograms. It does not make any sense to say I have a mass of 20 kilograms north. Mass is a scalar, does not have a direction. The value of your mass, 25 kilograms, is the magnitude. Okay? So, vectors are unique because the way we represent a vector is with an arrow. Okay? Now, any vector has a special notation. Oftentimes, you will see a vector represented as such. For example, force is a vector, so you could represent force like that. That is the notation for a force vector. Back to this. A vector is represented as an arrow, such that the length of the arrow represents the magnitude, and the direction of the arrow represents, you guessed it, the direction. Longer arrow, greater magnitude. Now, vectors, like scalars, can be added, okay? However, the difference being that when we add scalars, when you add 25 kilograms to 10 kilograms, you just add them and you get 35 kilograms. In a vector, you would add the vector in the so-called tip to tail. Meaning if you have two vectors, vector A and vector B, you would draw vector A, you would take vector B and you would put the tail of vector B on the tip of vector A, and then you would draw vector B, such that the resultant from the addition of vectors A, B is this vector, called the triangle rule. where when you add AB, the vector goes from here down to here. So this is your ultimate final point in the vector. Therefore, the addition of A and B can be represented by vector C that goes directly from the origin to the final point, such that you would write A plus B equals C. Now, finally, I want to begin to tackle the perspective and sort of outlook and mentality we're going to want as we go into the AP Physics 1 course. And this was a acronym derived from one of my teachers. It's called the Know, Find, Solve. Okay? In AP Physics 1, you are going to be given a lot of equations on your equation sheet. And with that fact, you are going to have more than one way to solve any given problem. However, each path that you can take to solve a problem requires a different set of information. Okay? So, the method that works for one problem is not going to work for a different problem if the different problem gives you different information and asks you to solve for the same quantity. Okay? So, whenever you approach a physics problem, your job is much less to understand the concept of what's going on and much more to focus on what is the problem telling you. Okay? What do you know? What is given to you? Like, let's say that you're given velocity, you're given some time, you're given an acceleration, you're given, and you're asked to find position. I'm not expecting you to understand what I just said, but my point is you should be able to very quickly discern the information and the quantities that the problem is giving you. Okay? Because AP Physics is not math, it's word problems. Okay? So it's not going to outright tell you velocity equals 10. It's not going to tell you that. It's going to say it in words, like this car is moving at 10 meters per second. And you're going to need to be able to discern from the words the quantity, the actual numerical value. And once you've discerned everything that the problem is giving you in numerals, then you will identify what exactly the problem is asking you for, okay? So the problem might say, where does the car end up? And you would need to recognize that that is asking you for the final position of the car. And finally, once you have what you know all crystallized out, and you know exactly what you need to find, now it's your time to try and use the equations given to you on your reference table to find an equation that uses all the values given to you and will spit out the value you need to find. And that comes from the S part of our acronym, SOLVE. Know, Find, Solve. Thank you guys for watching.